Okay, we have been talking about the mean, the median, and the mode, which are all considered measures of central tendency. Now, what I want to do today is talk about an applied example, and actually an example that is going to be potentially relevant for you in your life as a professional. And it is an applied example that once again underscores the fact that the mean, the median, and the mode are not the same thing, and that sometimes it's beneficial to look at one or the other when we're talking about describing a data set. So mean, median, and mode, they're all considered measures of central tendency. I want us to make sure that we keep in mind the goal that we have. These are descriptive statistics. So what I'm doing is I'm trying to describe a larger data set by using a limited number of descriptive statistics. Okay, so let's dive into this one, and we'll see if it makes sense for you. So suppose that you're done with your college education. Congratulations, right? That would be a good thing. You have your degree. You're ready to get out in the job market and make some money as a professional and help people and so on and so forth. Let's use this example. Suppose that you have your degree in physical therapy, and you're young and you're ready to hit the professional market, and you decide maybe you want to work in a big city for a little while, Boston or Atlanta or Los Angeles or something like that. And so you're looking at a couple of agencies at which you want to work. So let's say that you have an interview, you have two interviews. Let's say that at agency A, they have, let's say, 50 physical therapists that work in this big hospital, this clinic, or whatever it is. Okay, so it's a large agency, and you've been there, you've met the people, and this is an agency you're really interested in working with, and you like the people, and so on and so forth. Agency B, another large clinic. Let's say there are 50 physical therapists that work there as well, and you like this place equally well. And so one of the things that you might want to take into consideration, of course, is what is the salary, okay? So during the interview, you ask about the salary, and let's say that they're going to start you. So let's say your salary at A, and I'm going to just subscript this with A to keep this straight. This is a standard technique when we're doing these kinds of things. So your salary, let's say they're gonna start you at $70,000 a year. Not bad, okay? Not bad at all. In fact, that's probably higher than what you would start at, but let's live the fantasy, okay? Oops, this is subscripted B, right? And so, okay, you take that in consideration, and you go to the interview at agency B, and they also tell you that your starting salary is going to be $70,000 a year. Okay? So far, it's hard to make a decision, right? I mean, if you like both of these places equally well, and just for the sake of argument, we could say they're both in New York City or whatever. What I'm trying to say is they're equivalent in terms of what they're offering. So you decide, you go back for a second interview, so you're pretty sure that they're going to hire you. You go back for a second interview, you're trying to decide which one of these jobs that you're going to take. That's a nice problem to have, by the way, right? You have a choice between two. And so you think to yourself, you know what? Let's do this. I'm going to start at 70,000, but of course, you're good, you're qualified, and you're a go-getter, and so you know that you're going to work your way up the ladder. And so maybe what will help you decide here is asking about the average salary for physical therapists at this agency, okay? And so you ask the supervisor or the person that's interviewing you, well, what is the average salary for physical therapists in your agency? And they say, well, the average salary is $93,000 a year. And you're like, wow, okay, that's pretty cool, because you know that you're at least average. So after a while, you're going to, get to some point, more than your starting salary. And so you go to the second interview at agency B, and you ask the same question, right? What's the average salary for folks at agency B? And the response there is, well, the average salary for this agency is $81,000 a year. Well, I mean, if everything else is equal, and that's what we're going to assume for this example, you like the people in both situations, same size, it's in cities that you like, and so on and so forth. You're starting with the same salaries, but it looks like maybe you have more room to improve here for agency A. And so, from the data that you've collected, right, the information that you have, the evidence that you have, I'm going to, use those terms interchangeably. I think, right, what would you choose? Would you choose B or would you choose A? I suspect, and I would expect in many cases, that people would choose agency A, because the average salary for these 50 PTs is much higher than the average for B. So you choose to take the job at A. You tell people at agency B, sorry, I really liked your agency, but I'm going to go with another place, because even though they're offering you the same opening salary, looks like that the PTs are getting paid more in agency A. Okay? So, let's have fun with this, okay? Let's pursue this story. And there's a lesson here, okay? So you go to agency A, and you're working there, and after 6 months, you're off a probationary period, and maybe your salary goes up to 75,000, right? Wow, this is pretty cool, because I'm already higher than I was. Remember, for agency A, the average was $93,000 a year. Okay. So cool. All right. Well, 6 months into it, and we're at the holiday party. Okay. So you're at the holiday party, and it's a nice spread. There's free drinks, and there's cocktail franks, and there's shrimp, and so on and so forth. And so you're mingling with people, and you've got your friends that you've made in the agency and stuff, and you start talking to people, and you say, hey, listen, I know you don't have to tell me if you don't want to, but I was just wondering, how much you make a year. You've been here for a few years. What is your salary? And the person says, oh, I'm making 78,000. Okay, fine. And then you talk to someone else, and they say, oh, I make 75,000. You talk to someone else, and they say, oh, I'm making 69,000. Talk to someone else, I make 80,000. You talk to someone else, I make 74,000. You talk to someone else, you talk to someone else. Lo and behold, you've talked to dozens of your colleagues, and not a single one makes over $85,000 a year. And you're kind of thinking to yourself, I was told at the interview that the average salary was $93,000, and I've not met one person that makes over 90. And just for the sake of argument, let's say that you've talked to pretty much everybody at the holiday party, like 48 people, and nobody has made over $90,000. And you start to think to yourself, was I lied to? It seems strange that somebody would lie about something like that. But of course, if they want you to work at the agency, maybe they did. And then while you're contemplating this, all of a sudden the lights go down dim and the spotlight turns on. And through this double doors up on a balcony, the doors open and the spotlight is there. And you're like, what's this all about? And one of your friends, your coworkers said, oh God, this happens every year. This is the CEO of the company, and she's a physical therapist. And so she comes in and she says, welcome everyone, please have another drink. This is our time to celebrate the holidays and all of our success and blah, 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 blah. And your friend, your coworker says, yeah, and she makes $2.1 million a year. And you're like, oh my God. Which, by the way, is not uncommon, right? For CEOs and for the bigwigs in the corporation or in the hospital system or in the school system to make a huge salary. I mean, this is not uncommon. Well, so what does this have to do with statistics, right? And this is the thing that I sometimes try to impress upon students. When we're talking about all the textbook stuff and when we're doing problems with central tendency and when we're calculating the mean and the median, like that's all the nuts and bolts. But it's absolutely relevant here to our example. It's relevant to how you're going to make decisions, perhaps about what job you would have. And what is happening here with salaries of the physical therapists at this agency? Well, here's what's happening, okay? We have a lot of people down here, you and your coworkers are down here making this much money. Remember, in this case, the x-axis is salary, how much you're making a year, right? So you guys are down here, the 49 of you that aren't the CEO. And then we have the CEO, way out here, making, what did I say, $2.1 million, right? What kind of a distribution is this? This is a positively skewed distribution. In fact, and it's kind of an extreme tail out there. And so where you guys are making $70,000, $75,000, $69,000, maybe up to $80,000, the average for this distribution is $93,000 a year. Okay? In fact, the person interviewing you certainly didn't lie to you. Okay? They may have been just looking at the numbers. But what is happening here? Well, all of you guys are working here. When we put in the $2.1 million, when we calculate this average, right? Remember, the average is the only measure, the only measure of central tendency that takes into account every single score. So that 2.1 million is going to pull the average. It's going to pull that fulcrum out toward it, okay? And in fact, salaries for organizations, whether it's a hospital, a school, a corporation, a factory, whatever it is, salaries tend to be notoriously positively skewed. Okay? There's usually one or two or half a dozen, depending on what the size of the agency is, people making lots and lots of money, and then the majority of the workers are here. Okay? So, what does that mean? What does that mean? Well, if we want to describe this data set using measures of central tendency, you see how this is coming together? Okay? We talked about the abstract stuff, we talked about the textbook, and we calculated the median and blah, blah, blah. Okay? But now we're using an applied example. We have to take that information and see how it works in an applied setting. I try to do that for my students, okay? You have to pay attention. This is not like school book learning, and then I go into the real world and it's not relevant. Not for this class. That's not how it works. We do the school book learning stuff. We learn the concepts. Now let's apply to the real world, right? And so I would suggest in this case that the mean is not a good descriptor of what's going on with most of the population. I hope you agree, okay? Because this is really kind of screwing things up. It's pulling that mean outwards. Now this is the mean. I mean, we can calculate it. That could be the mean. Nobody's lying to you. This is the thing that, and again, I'm expressing a lot of my frustrations, right? Listen, people will lie to you. People will try to mislead you. That's why we need to learn this stuff to protect ourselves. I'm not going to blame the person that told me that the mean was 93,000 because that person is being truthful with me. But I know that salaries are notoriously positively skewed, so I suspect that the mean is not representative, that is not descriptive. Remember our descriptive statistics, okay? And so what is an alternative that we could use? Well, I mean, if these are 50 physical therapists, I'm assuming if I start at the bottom and start counting up, I'm assuming that we're going to get to the lowest 25%, the lowest 25 people, the lowest 25 people, that would make it a 50%, right? I would expect that the median in this case would be probably around here somewhere, because this is only one person out of 50. And it doesn't matter if they're 2.1 million or 1 million or 200,000 or 5 million. Once we get to here with our median, it stays there, okay? So, what's the lesson here, okay? Like I said before, in the abstract, when you have a skewed distribution, oftentimes the mean is misleading. So we're going to go with the median in this case. And in fact, when you look at governmental data, when you look at people who are careful with statistics, when they're looking at salaries, they will look at median salaries, not mean. Precisely because a couple of large salaries will make this so it's non-representative. And by the way, please don't use the term, it'll throw the number off, because I don't know what you mean when you say throw the number off, okay? Please be more articulate and say the mean in this case is not a good descriptor of this part of the data. This is misleading. That's what you're saying, right? It's artificially inflated. That's much better than saying that the numbers thrown off. We're in college now. We need to be more articulate, okay? Now, let me grab my eraser here. If in the interview, and I'm not lying about this, okay? If in the interview you ask the person, instead of asking what the mean was, if you ask what the median was, that would give you a better idea of what the distribution looks like, since the underlying distribution is skewed. By the way, if it wasn't skewed, the mean and the median would be close to the same anyway. But if you're aware that salaries tend to be skewed like this, you're much better off asking about the median. And I will tell you a secret. The person interviewing you will be impressed. Will be impressed. Because when you ask about the median, they will know that you're more savvy, that you're more educated than someone who's just going to ask about the mean. Okay? And you'll get better information. And in fact, if we go back to our A agency and B agency, you actually might be better off going to agency B if it's a normal distribution than going to agency A that's skewed like this, and this is a misleading number. Okay? Salaries are notoriously skewed. By the way, if we look at data such as home prices tend to be notoriously skewed as well. I mean, some of you live in neighborhoods like this. I know I do. The houses are, sort of, there's an average, this is where most people are. And then at the end of the cul-de-sac, there's this huge house with the lions on the pedestals and a big fountain in the middle and so on and so forth. What's going to happen is if we look at average home prices, that's going to be pulled out toward that, multi-millionaire house. And it's going to make it look like the neighborhood has a higher average, or that the distribution is out here more. I want to be careful, right? Because this is the average, but it's misleading. It doesn't represent where a lot of the distribution is. Okay. Home prices are notoriously skewed. Salaries are notoriously skewed. And so when you look to describe those data sets, you're much better off using the median. Why? Because the median is describing this distribution where the distribution is much better than the mean. Okay? And that's something that I hope that you will remember even after you complete this course, because it's a tool that you can use to, in a way, protect yourself, right? People may want to mislead you. People may mistakenly, if somebody doesn't know this themselves, they might report the mean and feel perfectly comfortable with that. But you're more sophisticated than that now. You're more sophisticated, and that should make you feel good. Okay, so be careful. By the way, the same thing can happen with a negative skew as well. Okay, so you can have the mean be pulled downward and not be representative of most of the distribution. The same kind of argument can be made for negatively skewed distributions. Okay? I hope that this real-world example, which might be relevant for you in a couple of years once you get your degree, or a year, or whenever it is, when you're making decisions, and again, this is another level of this example which I like, is that you're making decisions. You want some information upon which to make those decisions. Okay? And so, what you learn in this class can be helpful, I hope. Okay. So, using the median is better than the mean when you have a skewed distribution. And when I say better, I mean it's a better way to describe the data set. If you have a normal curve, which is very often because it's so ubiquitous, remember that term, then the mean is the gold standard. And the mean, one of the reasons is because it uses all the information. But if you have a skewed distribution, don't use the mean, it's going to be misleading. In the last video we talked about, if you have undetermined values, of course you can't calculate the median in a meaningful way, so the median is good in that case. The mode is used when we have categorical data because it's the only thing we can use. And then sometimes the mode is used, or bimodal is used, to describe the general shape of a curve. Okay? The mean is the gold standard, but there are exceptions. So I want to sort of finish up our discussion of measures of central tendency by talking about yet another problem, in a way, that you have to be careful of, that you have to avoid. And that is, sometimes people are dealing with two distributions that they want to combine. Okay? For example, I might have two sections of my statistics class, and I give them the same exam, and I grade the exams, and I get the descriptive statistics. I might want to combine those numbers and say, what is the overall average? And I typically do that when I have multiple sections, okay? Or we might have, two groups of people from some population, and I've collected data, and I might say, well, what does the overall mean? Okay, so let's do this example, and I want to show you again a potential problem that now you have the tools to deal with. Okay, so let's do this. Let's say that we have class A and we have class B. Okay. And class A has, let's say, 80 students in it. Okay, I'm going to use a lowercase n here instead of an uppercase n. I don't want that to confuse people. What I want to do in this case is I want to take these two samples and combine them into a group that I'm interested in. So these become a sample that samples that I'm going to combine. So I'm just going to use the n as the notation here, little n instead of an uppercase n. Let's say that this group has, let's say, 40 students. Okay. Now we're going to say, well, the mean for group A, and I'm using a different symbol here as well. This is an M, an uppercase M, rather than mu. Mu we're going to use when it's a population. M we're going to use when it's a sample. Okay, so the sample A, the mean for sample A, let's say the mean for sample A is, let's say 70. Okay, the mean for all of the exams is a 70. Let's say that the mean for sample B is 80. Now take a moment, make sure that you're okay with this terminology. Okay, this is the average for these 40 students, was 80% on the exam. Okay, if we want to do this, we can do this. Okay, for section A, there's 80 students. The mean for the exam is 70. All right? Now, we're going to combine these two groups, and we're going to get the overall average. Okay? Now, what a lot of people do, I've seen this in graduate school, I've seen this working with agencies, it's a very, very common thing that people do that's incorrect, a very common thing. Is they say, well, I got two groups, and I want to combine them. I want to get the overall average. So let me take the mean of the means. This is often what's happened. The mean of the means. Well, what is the mean of the means? 70 plus 80 divided by 2. 150 divided by 2. So the mean of the means for this example would be 75. And then people kind of go on their way and they're like, okay, that's the average. That's the overall average for the group. And I'm like, wait, whoa. That is wrong. This is demonstrably incorrect. And I'll tell you, if you tell somebody that you're in a meeting at your agency, your job or whatever, and they do the mean of the means, and you say, well, wait a minute, I think that's incorrect. I can tell you that sometimes people with more power than you will say, oh, no, we are correct. I'm like, well, let's think this through. Let's think this through a minute, okay? Let's think this through. This is incorrect, okay? Let's take a moment and think about what the average of all of the scores would be. And here's what I want to do. I want to do this. I want to say the overall average, and this time I'm using the mu because I'm going to put these two things together, so that's the population I'm concerned about. Is what? It's the sum of all of the x's, that is my overall sum for all the x's, divided by my overall number of people. First question, how many people do we have in both of the groups combined? What is our total number? Yeah, 120, right? I mean, I hope you got that. There's 80 in the first class, there's 40 in the second class. So you add those together, right? I mean, let's think this through. This is figure-outable. And how did you get that? How did you get that? Well, you did NA plus NB, 40 plus 80 is equal to 120. Okay? To get the overall mean, get the overall number of people, 80 plus 40. I think I might have misspoke there. I'm not going to rewind it. 80 plus 40 is 120, right? That's how you got that. Now we need the overall scores. I need to add up the scores for 120 people. Well, here's where we run into what looks like a problem, but I'm going to ask you to think this through. That's my job as a mentor, as a teacher, right? I don't know any of these individual 80 scores, so how can I add them up? I don't know any of these individual 40 scores, so how can I add those up? Okay, so it seems like we're against a wall here, like we don't have enough information. But we do. Let me show you. How do we get this number? Well, we added up these 80 scores and we divided by n. I guess in this case, if we want to say this. So 70 was equal to something divided by 80. Aha! Some of you are seeing the connection here, right? I mean, I'm firmly convinced that this looks like it's a problem that we can't solve precisely because most of the time we're solving for this, right? Get the number of scores, divide by n, you get this. Get the number of scores, divide by n, you get this. Get the number of scores, divide by n, you get this. I mean, you guys have calculated the mean hundreds of times, okay, by getting these values and solving for this. But it's a simple algebraic formula. If I have any two of these, I can calculate the third value, okay? So this is what I mean when I say this is figure-outable. We need to take our time and to think this through. So even though I don't know any of these individual scores here, I can certainly solve for the sum of x for group A, and it's 80 people. They have a mean of 70. I'm going to multiply that. 5,600 was the total for the students in group A. I still don't know individual scores. I don't need to know individual scores. I got this anyway. This is for A. Let's do the same thing for B. We have our mean, sum of x, n. So mean of 80, 40 students. Everybody with me? My sum of x in that case, 40 students times a mean of 80, 40 students times, 40 students times mean of 80, 3,200. Okay, 3,200. Okay, well, that's cool. I have the sum for all the people in A. I have the sum for all the people in B. I have total number of people in A, total number of people in B. Okay, so now I can do this. 5,600 plus 3,200 divided by 80 plus 40. Let's do this. 5,600 plus 3,200 equals, divided by 120, 73.33%. In fact, 75 is incorrect. The mean of the means in this case is incorrect. The correct overall average for these two groups is 73.33. Now, what you'll notice here, I hope, please take the time to notice. 75 is exactly in the middle of these two, right? I mean, that would have been our fulcrum, mean of the means. The actual mean of all of these scores is 73. That is, it's over here. It's pulled this way a little bit, okay? And that is because there's more people in A than there are in B, and so this class carries more weight. And in fact, this is called the weighted mean. The group with more people carries more weight. Okay? If Class B had more students, then we would see that the overall average was shifted closer to Class B. The class with more students carries more weight. Okay? If, and only if, these two sample sizes were, if these were equal, if it was 80 and 80, or if it was 40 and 40, then the mean of the means would work. However, that's the only case where it would work. And oftentimes when you're combining data, they're not the same size. Okay? Also, the good news is, if this was 80 and this was 80, we could do the same procedure here, and we would come up with 75. So this always works. The mean of the mean only works in one special situation, which is very uncommon. Okay? It's called the weighted means. When you're combining groups, you need to use weighted mean, not just the mean of the means. Hopefully, 3 years from now, when you're working somewhere and someone says, well, we'll just take the mean of the means, I hope a little neuron fires in your brain and says, well, I think there's a potential problem with that. and then you can help in solving it correctly, okay? Now, you might be thinking to yourself, so what? I'm never going to do anything like this or whatever. Well, you're already doing it. As a student, oftentimes, and I'll tell you how this is relevant to your life right now, oftentimes, students will be going through semesters, and all of a sudden they have a really good semester. Wow, I got a 3.87 this semester. That's awesome. And you're waiting to get your grade report, and wow, your cumulative GPA is going to go way up, right? Because you now have this 3.8, and you get your grade report, and you find that your cumulative GPA only went up a tiny little bit. You're like, what? That's crazy. I thought it was going to go up more. Well, guess what? This has to do with weighted means, folks. This has to do with weighted means. It's a very common disappointment that students have when they all of a sudden have this great semester, and it only just nudges their overall GPA, okay? Here's how it works. Here's how it works. Suppose that your previous cumulative GPA, might be 3.42, right? And then you have your current semester GPA, what did I say? 3.87 or whatever, okay? And you're like, wow, that's going to make this go up a lot. But remember, your previous GPA might be based on 65 total credits, right? This current GPA might be based on 12 credits, right? I mean, maybe that's why you did so well. You took, one less class so you can really focus on your studies, and you end up really doing well, okay? Well, 65 credits at this value, 12 credits at this value. This is exactly the same as what we just talked about, okay? This is why I try to combine, here's the concept, here's the abstract math stat stuff, but it actually applies to this, something that you're all familiar with, okay? And, I try to do that, but it's also incumbent upon you to try to see how the stats concepts are relevant to some of the things that you might be, dealing with. In this case, weighted means. So that your cumulative GPA, the overall GPA, is not the average of these two, not by any stretch of the imagination, right? 12 credits of 3.87, 65 credits of 3.42. And so rather than being right in the middle, right, your new cumulative, it's going to be weighted more this way. So your cumulative GPA might go up to 3.5, okay? Very disappointing. And it is disappointing. If you have a semester like this, man, it's too bad that it didn't, have more weight. The good news, there's always pluses and minuses, right? Double-edged sword kind of a thing. If you have a really terrible semester, like let's say, wow, you really kind of bombed things, and maybe you had some personal stuff going on and whatever, and your GPA is 2.25 for this semester. The good news is that this is still going to carry more weight. So a bad semester is not going to hurt you as much as you thought, but a good semester is not going to help you as much as you thought. Okay? So, I hope that this makes sense, and I hope that it keeps you motivated to learn statistics so that then you can apply these basic concepts to more specific or applied situations that you'll find yourself. Okay, next video we'll talk about a new concept. That is, we're going to move into talking about variability. Okay.